Okay, so we discussed non-linear plot for enzyme catalysis. Next we have to see linear plot, rate versus concentration of substrate. Okay, Michaelis-Menten kinetics explains what? How rate of enzyme catalysis reactions changes with concentration of substrate. Okay, so before going to linear plot, we have to see two terms. One is turnover number. Turnover number. Turnover number. Okay, simple questions they are giving based on turnover number and catalytic efficiency. Turnover number and catalytic efficiency. So turnover number, that is given by K2. K2 is nothing but what? Rate constant for product formation step. Rate constant for product formation steps. So turnover number is nothing but it is the number of substrate molecules that are converted to product by an enzyme within a given time. In a given time, how many substrate molecules are converted to product by an enzyme? That is called as turnover number. So how many substrate molecules are converted to product? That is given by what? Second step rate constant. That is given by second step rate constant. So indirectly turnover number is given by what? K2. So write the definition of turnover number. It is the number of substrate molecules. It is the number of substrate molecules. It is the number of substrate molecules that are converted into product by an enzyme per unit time or in a given time, and that are converted into product by an enzyme per unit time. So the unit for turnover number is what? Time inverse. Within a given time, how many substrate molecules are converted to product by an enzyme? That is called turnover number. Next one, second one, catalytic efficiency. Catalytic efficiency, that is given by K2 by Km. Okay, in the last class concept we discussed, if Km is equal to concentration of S, V is equal to V max by 2 we got. Okay, so this catalytic efficiency is nothing but K2 indicates what? How many substrates are converted to product. K2 indicates how many substrate molecules are converted to product. So Km indicates here per a given concentration of substrate. And for a given concentration of substrate, how many substrate molecules are converted to product. So we are giving 100 substrate molecules to enzyme. Okay, out of 100 substrate molecules, how many are converted to product by an enzyme? That is called catalytic efficiency. That means it is a measure of how efficiently enzyme converts substrate molecules to product. Okay, it is a measure of how efficiently enzyme converts substrate molecules to products, and that's why it is called catalytic efficiency. Okay, write the definition. For a given concentration of substrate, for a given concentration of substrate, for a given concentration of substrate, comma, for a given concentration of substrate, comma, the number of substrate molecules, the number of substrate molecules, the number of substrate molecules, the number of substrate molecules converted to product, the number of substrate molecules converted to product by an enzyme, the number of substrate molecules converted to product by an enzyme is called is called catalytic efficiency. Is called catalytic efficiency. Okay, unit if you see, K2 unit time inverse, that is first order rate constant. Okay, time inverse. Next Km, concentration. It is related to what? Concentration. For a given concentration we are writing. So concentration inverse and time inverse, concentration inverse. So that is the catalytic efficiency. Okay. So this is simply for a given concentration of substrate. And how many of them are converted to product by an enzyme in a given time? That is called catalytic efficiency. So you remember this. Turnover number is represented by what? K2. Catalytic efficiency is represented by K2 by K1, Km. Okay. Next we see linear plots. And next we see linear plots. In that first one, Lineweaver-Burke plot. Lineweaver-Burke plot. This is also called as double reciprocal plot. Lineweaver-Burke plot or double reciprocal plot. It is called double reciprocal plot since inverse of rate versus inverse of substrate concentration we will take. The graph is taken, okay, 1 by V versus 1 by S. That's why it is called double reciprocal plot. If you take initial concentration 1 by S naught, 1 by V naught we indicate. Okay. So Lineweaver-Burke plot or double reciprocal plot or 1 by V versus 1 by S plot. So what is the expression for rate equation we have? V is equal to V max into concentration of S. Once you check on, right, this is the rate equation we have. V is equal to V max into concentration of S by Km plus concentration of S we have. So we are taking inverse of V and so if you write inverse of the above equation, so 1 by V is equal to Km by V max, Km by V max into 1 by S plus S by V max into S. SS gets cancelled. We get 1 by V max. So this is some linear relationship we are getting. So this linear plot is given by Lineweaver-Burke. So that is called Lineweaver-Burke plot or double reciprocal plot. It is called double reciprocal plot since inverse of rate versus inverse of substrate concentration we are taking. This is in the form of y is equal to mx plus c. This is in the form of y is equal to mx plus c. So now slope is equal to what? Km by V max and intercept 1 by V max. Previously repeatedly questions given and based on this Lineweaver-Burke plot. Many times questions given from this equation. So the nature of questions are they are asking to calculate Michaelis constant. If slope and intercept data is given, how to calculate Michaelis-Menten constant. If slope and intercept data is given, how to get catalytic efficiency. If slope and intercept data is given, how to calculate turnover number. So all those we can calculate by using this equation. Okay, first you write linear plot. 1 by V versus 1 by concentration of S. We are getting straight line. Slope is equal to Km by V max, intercept is equal to 1 by V max. How to get Km and Km is nothing but what? Km is nothing but what? Slope by intercept. If you do slope by intercept, what happens? And V max gets cancelled. V max gets cancelled. We'll get Km. So Km is nothing but slope by intercept. Michaelis-Menten constant. Michaelis-Menten constant is nothing but slope by intercept. Okay, slope by intercepted. Slope is here Km by V max. 1 by intercept. 1 by intercept means reverse we will get V max. So V max gets cancelled. So slope by intercept is nothing but Km. Next, how to calculate turnover number? How to calculate turnover number K2? Here slope is nothing but R, you write like this only. Km by what? K2 into E naught. Okay, so K2 we want and K2 we want. Here also intercept, and intercept is nothing but 1 by K2 into E naught. Intercept is nothing but 1 by K2 into E naught. V max is nothing but what? K2 into E naught. So turnover number we can get like this, and turnover number is 1 by intercept into E naught, and 1 by intercept into E naught. Check 1 by intercept into E naught, and 1 by intercept means what will get, and reverse, and 1 by K2 into E naught reverse, that means K2 into E naught. K2 into E naught by E naught. So E naught gets cancelled, we are getting K2. So turnover number is nothing but 1 by intercept into E naught. This simple questions they are giving for 4 marks, and and next one, catalytic efficiency. What is catalytic efficiency? K2 by Km. Catalytic efficiency K2 by Km. So catalytic efficiency can be obtained by taking 1 by slope into E naught. Catalytic efficiency is obtained by taking 1 by slope into E naught. 1 by slope into E naught. Once if you do 1 by slope into E naught, and so 1 by slope and reverse of this means what will get? K2 into E naught by Km. K2 into E naught by Km, that is 1 by slope. Next into what we have? E naught. So E naught gets cancelled. What we are getting? K2 by K1. That is nothing but catalytic efficiency. So these three are important. Michaelis-Menten constant can be obtained by slope by intercept. Turnover number can be obtained by 1 by intercept into E naught. Catalytic efficiency is obtained by 1 by slope into E naught. Okay, some more points if you see based on Lineweaver-Burke plot. Okay, first you write up to here. Next, previously we got if concentration of S is equal to Km. If concentration of S is equal to Km, then what about rate we got? If concentration of S is equal to Michaelis-Menten constant, rate obtained is what? Half of the maximum rate. Half of the maximum rate. V max by 2. So similarly, if you take 1 by concentration of S is equal to 1 by Km, if you take inverse of this, and if you take 1 by S is equal to 1 by Km, then 1 by V obtained is what? 2 by V max. So if 1 by concentration of S is equal to 1 by Km, 1 by V value obtained is what? 2 by V max. Okay, so here I am writing, if 1 by S is equal to 1 by Km, if 1 by S value is 1 by Km, 1 by V obtained is what? 2 by V max. If 1 by S is equal to 1 by Km, 1 by V obtained is 2 by V max. And finally, if you extend this 1 by v up to x-axis, and here 1 by v value becomes what? Here 1 by v value becomes 0. Okay. Now for which value of 1 by s, 1 by v becomes 0. For which value of 1 by s, 1 by v becomes 0. So in this equation you may substitute 1 by v 0 and get the expression for what? 1 by s. Let us consider this is equation 4. Okay, let us consider that is equation 4. So from 4, okay, from 4, if 1 by v is equal to 0, okay, at this point what about 1 by v value? 0. It touches x-axis. So that if you substitute in 4, 0 is equal to Km by V max into 1 by concentration of S plus 1 by V max. So if you bring this left side, 1 by S into Km by V max, that is equal to minus 1 by V max. So V max gets cancelled. We are substituting 1 by v is equal to 0. At this point 1 by v value is 0. What is 1 by s? That we are calculating. So now finally 1 by s is equal to what? Minus 1 by km. So therefore if 1 by concentration of s is equal to minus 1 by km, then 1 by v value is equal to what? 0. If 1 by s is equal to 1 by km, minus 1 by km, then 1 by v value is 0. That means here 1 by s value is what? Minus 1 by km. If it is 1 by km, 2 by v max. If it is minus 1 by km, its value is 0. This is about line wear Burke plot and double reciprocal plot, 1 by v versus 1 by s plot. And one more linear plot we have, ED obst plot. Last one, ED obst plot. Next one, ED obst plot. That is V by S versus V and V by S versus V. ED obst plot, V by S versus V. So what is the expression for V? We have V max into concentration of S by Km plus concentration of S. So this we have to convert into V by S versus V form only. V by S versus V plot, that is called ED obst plot. So if you multiply this, V into Km, V Km plus V into S, Vs, that is equal to V max into concentration of S. Okay, simple multiplication, V into Km, V Km plus V into S. Now if you bring this S right side Vs, and if you take concentration of S common, we get V Km is equal to concentration of S common, we get V max minus V. V max minus V. And finally, if you bring this S left side, V by S. V by S is equal to, and if you bring this Km right side, V max by Km minus 1 by Km into V. So now we got V by S versus V. Based on this, only once a question given and for 4 marks based on this equation. This is in the form of what? Y is equal to C plus mx. This is in the form of y is equal to C plus mx. So intercept is equal to what? V max by Km, and slope is equal to minus 1 by Km. So from slope we can calculate what? Michaelis-Menten constant we can calculate. Negative of slope gives Km. And Vmax we can calculate by minus intercept by slope. Minus intercept by slope gives what? And Vmax. Vmax is nothing but minus intercept by slope. Okay, and if you do minus C by M, minus C means minus Vmax by Km. 1 by slope means minus Km. So Km gets cancelled, minus into minus plus. So Vmax and Km we can calculate. And Vmax and Km we can calculate based on ED-OBST plot. So this is the question given. And Vmax and Km they asked to calculate for 4 marks. Or here Km we are getting, that Km if you substitute here we will get C. Sorry, Vmax, and here we will get Km value. That Km value if you substitute here we will get Vmax. Okay, so this is about effect of substrate concentration on rate of enzyme catalysis reactions based on Michaelis-Menten mechanism. Okay, next we have to see briefly what is the effect of temperature and what is the effect of pH on enzyme catalysis reactions. Okay, right, effect of temperature on enzyme catalysis reactions. Effect of temperature on enzyme catalysis reactions. Effect of temperature on enzyme catalysis reactions. It is observed that as temperature increases, generally what about rate of reaction? Increases. As temperature increases, rate of reaction also increases. So as temperature increases, rate of reaction increases up to a certain temperature only. For enzyme catalysis reactions, rate increases up to a certain temperature only. That is called optimum temperature. As temperature increases, rate of reaction increases up to a certain temperature only. That is called optimum temperature. Above optimum temperature, what happens? Above optimum temperature, rate decreases and rate of reaction decreases. Above optimum temperature, what happens? Again, rate decreases. So rate reaches maximum value at optimum temperature. Rate reaches maximum value at optimum temperature, and above optimum temperature, again what happens? Rate of reaction decreases. Since above optimum temperature, what happens? If you see, above optimum temperature, denaturation of proteins may occur. Denaturation of proteins may occur. So enzyme structure may be changed, and what happens? Enzyme structure changes. Some bonds may participate in the breaking. Some bonds may participate in the breaking. Cell death may be observed. Cell death may be observed. Okay, above optimum temperature, what happens? Denaturation of proteins occurs, or enzyme structure may be changes. So because of that, what happens? Activity of enzyme decreases. Above optimum temperature, what happens? Activity of enzyme decreases, so rate of reaction decreases. So above optimum temperature, rate decreases. That is due to denaturation of proteins, or due to some breaking of bonds, or due to change in the structure of enzyme. So activity of enzyme decreases, so rate of reaction decreases. So if you plot a graph between rate versus temperature, so up to a certain temperature only it increases, that is called optimum temperature. After that again rate decreases. If you boil egg, what happens to entropy? And you discussed. If you boil egg, what happens to entropy? Increases. Okay, since that is also due to what? Denaturation of proteins. Enzyme structure will be changed. Okay, irregular structure we will get. That's why disorderness increases, entropy increases. And last one, effect of pH. And what is the effect of pH on enzyme catalysis reactions? Effect of pH on enzyme catalysis reactions, same and as pH increases, rate increases up to a certain pH, called optimum pH. As pH increases, rate increases up to a certain pH called optimum pH. So above optimum pH, so rate decreases again. Above optimum pH, rate again decreases. So generally the pH at which it exists as deuterion, at that we may observe optimum rate. Okay, that is around 7. You may verify pH values for deuterions, some of the amino acids. In amino acids you may get. What about pH values? And around 7 I think. So around 7 pH we will get maximum rate of reaction. Around 7 pH we will get maximum rate of reaction. Sorry, rate pH. So I am explaining briefly only, Andy. So up to certain pH it increases and again it decreases. So for that also some derivations are there. I am not going to that part, Andy. So far no questions given from these two parts, and temperature and pH part, no question given. Okay. So generally maximum rate is observed around pH 7 or where it exists in the form of deuterion. Okay, right? This is about enzyme catalysis reactions, Andy. So what are the various points you have to remember, Andy, regarding enzyme catalysis reactions? So various points you have to remember are: what is the expression for concentration of ES? What is the expression for concentration of ES, Andy? K1 into E0 into S, or E0 into S by simply Km plus S. Antenandi? Where Km, Michaelis-Menten constant, that is K2 plus K minus 1 by K1. Antena chudandi. The expression for Michaelis-Menten constant is K2 plus K minus 1 by K1. Next V. V is nothing but K2 into ES. So K2 into ES, and this is E0 into S by Km plus S. K2 into E0 also we can write as V max. K2 into E0 also we can write as V max. Then V by V max. V by V max is called fraction of reaction completed. Fraction of reaction completed. Concentration of S by Km plus concentration of S. Concentration of S by Km plus concentration of S, that gives fraction of reaction completed. Next one, at low concentration of substrate follows which order kinetics? First order kinetics. At high concentration of substrate, zero order kinetics. So if you plot a graph between, before that, if concentration of S is equal to Km, then rate obtained is what? Half of the maximum rate. If concentration of S is equal to Km, V is equal to V max by 2 or K2 into E naught by 2. So if you plot a graph between rate versus concentration of S, we'll get a graph like this. Okay. Here it reaches at high concentrations, reaches maximum rate, that is V max. If concentration of S is Km, rate is what? V max by 2. So this type of increase is called asymptotic increase. Asymptotic. So in one of the book it is given, with concentration of substrate rate increases asymptotically. With concentration of substrate rate increases asymptotically. With concentration of substrate rate increases asymptotically. Next, turnover number not required. Lineweaver-Burke plot. What about Lineweaver-Burke plot or double reciprocal plot? 1 by V is equal to Km by V max. Km by V max into 1 by concentration of S plus 1 by V max. Okay. So from this Km, Michaelis-Menten constant is nothing but slope by intercept. Turnover number K2 is nothing but 1 by intercept into E naught. Catalytic efficiency K2 by Km, 1 by slope into E naught. Okay. Next one, if 1 by S is equal to 1 by Km, then 1 by V is equal to what? 2 by V max. Reverse we will get. Here V max by 2, here we will get 2 by V max. And one more equation we discussed, if 1 by S is equal to minus 1 by Km, then 1 by V value is 0. So these are some conclusions from Lineweaver-Burke plot. And finally ED obst plot, V by S versus V. V by S versus V. What is the equation we got? V by S is equal to V max by Km 1 by Km into V. Okay. So this is intercept, this is slope. Slope is equal to minus Km, minus 1 by Km. So from slope we will get Km. That if you substitute here, we can calculate V max. So these are some of the points you have to remember regarding enzyme catalysis. Okay, now we see some questions based on enzyme catalysis. Okay, this is the direct question given in TS Genco Chemist exam. Right. In an enzyme catalyzed reaction, under high substrate concentration, under high substrate concentration, and when the rate of formation of product and when the rate of formation of product and when the rate of formation of product is of the maximum rate comma is of the maximum rate comma Michaelis-Menten constant is equal to in an enzyme catalyzed reaction comma under high substrate concentration and when the rate of formation of product is of the maximum rate, Michaelis-Menten constant is equal to options: concentration of E, concentration of S, K into E naught, concentration of ES. Concentration of S, right? If Km is equal to concentration of S, or if concentration of S is equal to Km, then what about rate and half of the maximum rate? So in the question it is given, if rate is half of the maximum rate, then what about Km? Km is equal to what? Concentration of substrate. That is option 2. If Km is equal to S, V is equal to V max by 2. Next one, this is also given in TS Genco based on Lindemann's theory, right? According to Lindemann theory, comma, in a unimolecular reaction, A gives rise to P. In a unimolecular reaction, A gives rise to P, proceeds via an intermediate A star. Where A star is. Options: activated complex, molecule with high translational energy, molecule with high vibrational energy. Fourth one, inert complex. So A star is nothing but what? Molecule with high vibrational energy, or that is said to be vibrationally excited molecule. Exchange of energy takes place between A and A. Inelastic collision occurs. During that collision, transfer of energy takes place. We'll get vibrationally excited molecule. So next one. This is given in CSIR for 4 marks. V max and Km for enzyme catalyzed reaction, are 2 into 10 power minus 3 m second inverse, 2 into 10 power minus 3 m second inverse, and 1.0 into 10 power minus 6 m, 1.0 into 10 power minus 6 m respectively. Right, continuation. The rate of the reaction when the concentration of substrate is 1.0 into 10 power minus 6 m, 1.0 into 10 power minus 6 m is Directly we can guess అండి. What is the rate if the concentration of substrate is 1 into 10 power minus 6 m? 2 into 10 power minus 3? 1 into 10 power minus 3. Here concentration of Km and S are same. So rate obtained is nothing but half of the maximum rate. That means by T if you do 1 into 10 power minus 3. And that is the rate. Options given like this. 3 into 10 power minus 3 m second inverse. 1 into 10 power minus 3 m second inverse. 2 into 10 power minus 3 m second inverse. 0.5 m second inverse. Okay, that is option 2. Okay, here what is given? Concentration of S and Km both are same. So V is nothing but V max by 2. V max is given 2 into 10 power minus 3 m second inverse by 2. So we get 1 into 10 power minus 3 m second inverse. Okay, if you don't get idea, you have to substitute in this equation, and V is equal to, we have V max into concentration of S by Km plus concentration of S. In this you may substitute V max value, Km value given, S value also given. You may substitute in this equation, you will get V value. Okay, 2 into 10 power minus 3. S is 1 into minus 6. Here Km plus S and 1 into 10 power minus 6 plus 1 into 10 power minus 6. 2 into 10 power minus 6 gets cancelled. 2 gets cancelled. So we get 1 into 10 power minus 3. Okay. So next one and next one given for 4 marks. The Lineweaver-Burke plot of rate inverse versus substrate concentration inverse. So 1 by V versus 1 by S. The Lineweaver-Burke plot of rate inverse versus substrate concentration inverse for an enzyme catalyzed reaction. For an enzyme catalyzed reaction following Michaelis-Menten mechanism, MMM. Following Michaelis-Menten mechanism, comma, following Michaelis-Menten mechanism, comma, y-intercept is 5000 m inverse second, comma, the initial concentration of enzyme is 1 into 10 power minus 9 m. 1 into 10 power minus 9 m. The turnover number is direct question and options. Sometimes they are giving like this, and instead of giving 1 into 10 power minus 9 m, they are giving nanomolar. Okay, nanomolar concentration. Which option? 4. turnover number is nothing but what? 1 by intercept into initial concentration of enzyme. 1 by intercept given 5000. We can write 5000, 5 into 10 power 3 into E naught, that is 10 power minus 9. 1 by 5 means 0.2. 3 minus 9 minus 6. If you bring to numerator 10 power 6. 0.2 into 10 power 6, that we can write as 2 into 10 power 5. Time inverse kada, unit time inverse and second inverse. Here time is given in seconds, so second inverse. So in 1 second 2 into 10 power 5 substrate molecules are converted to product. Next one andi. For an enzyme catalyzed reaction, comma, the Lineweaver-Burke plot gave following data. For an enzyme catalyzed reaction, the Lineweaver-Burke plot gave following data. Slope is equal to 40 seconds. Slope is equal to 40 seconds. Intercept is equal to 4 m inverse second. Intercept is equal to 4 m inverse second. Next, and E naught is equal to 2.5 into 10 power minus 9 m. 2.5 into 10 power minus 9 m. What is the catalytic efficiency? In liter per mole per second? What is the catalytic efficiency in liter per mole per second? M inverse, second inverse. And what is the unit for catalytic efficiency? And time inverse, concentration inverse. Time inverse, concentration inverse. So time inverse, S inverse, concentration inverse, moles per liter inverse, we will get liter per mole. So calculate catalytic efficiency. And options given: 10 power 5, 10 power 6, 10 power 7, 10 power 4. What is the formula? And catalytic efficiency is equal to 1 by slope or intercept. And slope into E naught. Slope into E naught. So 1 by slope 40 seconds into E naught. 2.5 into 10 power minus 9. 2.5 into 4 is 10. And 2.5 into 40 means 100. 100 into 10 power minus 9. That means we'll get 10 power minus 7. If you bring to numerator 10 power plus 7. So that is option 3. 1 by slope into E naught. Similar question given for 2 marks. And the data given like this, directly I am giving data. Slope given 40 seconds. E naught given 2.5 micromolar. What about catalytic efficiency? This is given for 2 marks. And options given: 40, 10 power minus 4, 10 power 7, 10 power 4. Almost similar type of data. In the place of nanomolar, it is given micromolar. And 10 power 4. And here 10 power minus 6 into 10 power 2. So 10 power minus 4 will get, if you bring to numerator, 10 power plus 4. Option 4. 1 by slope, that is 40 into E naught. 2.5 into micromolar means 10 power minus 6. 2.5 into 40, that is 100. 10 power 2. So 2 minus 6 minus 4. So if you bring to numerator plus 4. 2 power plus 4 and unit what will get, and m inverse second inverse will get, m inverse second inverse. Next question. Next one. This is given for 4 marks. In an enzyme catalyzed reaction, in an enzyme catalyzed reaction, in an enzyme catalyzed reaction, write this mechanism. So Michaelis-Menten mechanism is given. In an enzyme catalyzed reaction, E places K1 forward rate constant, K minus 1 backward rate constant, K2 for product formation. Continuation, K2 is equal to 3.42 into 10 power 4 second inverse, and if E0 is equal to 1 into 10 power minus 2 mole per decimeter cube. Decimeter cube is nothing but liter, moles per liter, and K2 is equal to 3.42 into 10 power 4 second inverse, and if E0 is equal to 1 into 10 power minus 2 moles per decimeter cube. Continuation, the magnitude of maximum velocity, the magnitude of maximum velocity and turnover number R, the magnitude of maximum velocity and turnover number R. Okay, direct question and options. 3.42 into 10 power 2 moles per decimeter cube second inverse, comma, okay, Vmax and turnover number we have to calculate, comma, 3.42 into 10 power 4 second inverse. Option 2, 3.42 into 10 power 6, same units, 3.42 into 10 power 4, 3.42 into 10 power 4, 3.42 into 10 power 6, 3.42 into 10 power 4, 3.42 into 10 power 2. Which option? Right. Turnover number is nothing but what? K2. So what is K2 and 3.42 into 10 power 4. So these two are not correct. Okay, turnover number is nothing but K2. K2 value is given directly. 3.42 into 10 power 4 second inverse. Vmax. What is the expression for Vmax? K2 into E0. Vmax is nothing but K2 into E0. So if you multiply those two, what we get? And 3.42 into 10 power 4 into 10 power minus 2. So 10 power plus 2. Units, moles per decimeter cube per second. So option 1. Option 1 and next one. This is given for 4 marks. slope and intercept obtained, slope and intercept obtained, slope and intercept obtained from, slope and intercept obtained from 1 by rate, 1 by rate against 1 by rate against 1 by concentration of substrate. Slope and intercept obtained from 1 by rate against 1 by concentration of substrate of an enzyme catalyzed reaction, or of an enzyme catalyzed reaction, or 300 and 2 into 10 power 5, 300 and 2 into 10 power 5 respectively. The Michaelis-Menten constant is, the Michaelis-Menten constant is, what is Km value, and if slope and intercept are given, slope ki intercept ki units ఏ ఉండాలి, m inverse second, slope ki second. You may write slope unit S, intercept unit m inverse S. What is Km value? How to get Km andi? From Lineweaver-Burke plot. Slope by intercept. Direct question, slope by intercept, that is 300 seconds by 2 into 10 power 5 m inverse second. So m we will get. What the unit for Km is m. Okay. Km is equal to 300 by 2 and 150 into 10 power minus 5 m, or we can write it as 1.5 into 10 power minus 3 m, 1.5 into 10 power minus 3 m. Okay, next question. Based on ED upstream plot and this is given for 4 marks. In the Michaelis-Menten mechanism, in the Michaelis-Menten mechanism, in the Michaelis-Menten mechanism, for enzyme catalysis, for enzyme catalysis, the Michaelis-Menten mechanism for enzyme catalysis, comma, the expression obtained is, the expression obtained is V by E naught into S is equal to 1.4 into 10 power 12 minus 10 power 4 V by E naught. The expression obtained is V by E naught into S is equal to 1.4 into 10 power 12 minus 10 power 4 V by E naught. The values of K2, the values of K2 and K in the bracket Michaelis constant, the values of K2 and K in the bracket Michaelis constant respectively are options 1.4 into 10 power 12, 1.4 into 10 power 12 comma 10 power 4, 1.4 into 10 power 8 comma 10 power 4, 1.4 into 10 power 8 comma 10 power minus 4, 1.4 into 10 power 12, comma 10 power minus 4. So this you may convert into ED upstream plot and V by S versus V, and then you may try. You convert into ED upstream plot. What is ED upstream plot and V by S is equal to V max by Km into V. So to convert into that form, we have to multiply with E naught, and if you multiply the above equation with E naught, we'll get V by concentration of S is equal to 1.4 into 10 power 12 E naught minus, okay, here E naught gets cancelled and here also E naught gets cancelled, minus 10 power 4 into V. So now if you compare these two equations, in the place of 1 by Km, what we have? In the place of 1 by Km, what we have? 10 power 4. That means Km value is 10 power minus 4. Okay, so 1 and 2 are not correct. Km value is 10 power minus 4. Next, if you compare, okay, intercept, and in the place of V max by Km, what we have? In the place of V max by Km, we have what? 1.4 into 10 power 12 into E naught. But V max we can write as K2 into E naught. K2 we want to calculate. K2 into E naught by Km. So E naught gets cancelled. So K2 is equal to 1.4 into 10 power 12 into Km value. Km value is 10 power minus 4. So we'll get 1.4 into 10 power 8. 1.4 into 10 power 8. That is option 3. Okay, right, there are some questions based on enzyme catalysis reactions, and right, with this enzyme catalysis reactions completed, so evening we will discuss collision theory, transition state theory, and if time permits we will discuss salt effect also. Those three concepts we have. So afternoon timings 2 to 4:30, okay, 2 to 4:30 p.m. okay na, right. Okay, thank you, and if you have any doubts you may ask me. Okay, 2 to 4:30 p.m. afternoon timings.